All right, let's get right into it. For just about any business out there, figuring out how much a customer is going to be worth over their lifetime, well, that's pretty much the holy grail. It's what drives your marketing budget, your product roadmap, everything. But the real question is, how do you get it right? So, if you were to ask a data scientist today how they tackle this, you'd probably get a very confident answer. Oh, that's easy. Just throw a powerful machine learning model at the data. But what if I told you that that very first instinct is actually the number one mistake people make? It's a huge trap. And here's the trap. It's assuming that a beefy machine learning model, something like XGBoost, which is, don't get me wrong, an amazing algorithm, can solve this all by itself. It's the go-to modern solution, but it's missing a massive piece of the puzzle. It just doesn't see a fundamental truth about how customers actually behave. To really understand this, we have to get to the core of the problem. And it all hinges on one simple but critical question. How does a customer say goodbye? Because that's where we find what I like to call the ghost in the data. Think about it like this. There are really two worlds of customer churn. On one side, you've got subscription businesses like Netflix. When you decide to leave, what do? You log in, you go to your account, and you click cancel. It's a clear, obvious, totally observable event. But then think about a store like Amazon. You don't send them a breakup email when you're done. You just stop buying. You quietly fade away. That silent departure, that's what we call unobservable churn. And that is the ghost in your data. It's this invisible state change. See, a pure machine learning model that's only trained on when people buy stuff has no way to tell the difference between a customer who was gone for good and one who's just taking a little break between purchases. To the model, they look exactly the same. So, how do we find this ghost? Well, this is where we need to pull out a different kind of tool from our toolbox. It's not about prediction in the traditional sense. It's about getting a probabilistic vital sign for every single customer. Class of models called Til You Die, or BTYD for short. The beautiful thing about them is how simple they are. They don't need 100 different features about a customer. Nope, they just need 3 simple things. Recency, when was their last purchase? Frequency, how often do they buy? And age, how long have they been with us? That's it. From just those 3 things, they can model the natural rhythm of a customer's buying habits versus the probability that they've silently dropped out. And what you get out of a BTYD model is this one incredibly useful number, a probability of being alive score. Seriously, think of it like a vital sign from a doctor's visit. A customer who just bought something last week, they might have a 99% probability of being alive. But that other customer who used to buy all the time but hasn't shown up in a year, their score might be down at 10%. It's a calculated risk, not just a guess. Okay, so this is where it all comes together. We've got our probabilistic BTYD model on one side and our powerful machine learning model on the other. The real magic, the big breakthrough here, isn't about choosing one or the other. It's about fusing them together to create a hybrid model that truly gets the best of both worlds. And the process is so simple, it's beautiful. Here's how it works. Step 1, you run your BTYD model to get that probability of being alive score for all your customers. Step 2, and this is the key, you take that score and you add it to your data set as a brand new feature. Then, step 3, you train your big, powerful XGBoost model on this new enriched data. You're basically handing the machine learning model a cheat sheet that says, hey, pay attention, this person is probably gone, but this one is very likely to come back. All right, so that all sounds really clever and logical, right? But the million-dollar question is, does this hybrid approach actually perform better in the real world? Or is it just a neat idea on a whiteboard? Let's see what the evidence says. And the answer, it turns out, is a pretty strong yes. This isn't just a theory. The research really backs it up. You can see here that recent studies are all pointing in this direction. One paper from early 2025 literally proposes this exact hybrid setup. And it's not a one-off thing. Multiple studies confirm that these hybrid techniques just flat out beat single models. One journal even found that using XGBoost this way improved accuracy by 22% over other methods. The trend is crystal clear. Fusing these models together is the way to get more robust and accurate predictions. So this gives us a really practical guide on when to use what. When is the hybrid model the clear winner? It's when you have transaction history plus other cool features about your customers and when their behavior kind of follows a predictable pattern of slowing down over time. It gives you the best of both worlds, incredible accuracy, and you can still explain why it's making its predictions. Now, could a pure ML model still work? Yeah, maybe for brand new customers who have no history yet, or if you're in a situation where you need predictions in literal milliseconds. So we've walked through the why, and we've seen the proof that this works. Now let's talk about actually putting this thing into practice. Okay, just a quick but really important heads up before we go any further. The dataset we're going to be using today, well, it has some known issues. It's a little biased. So I want you to think of what's coming next as an exercise in learning the how, the process, the technique, not as a definitive proof that it'll work miracles on this specific set of data. The goal today is to master the method itself. And that's a wrap on the introduction. So the big takeaway is that by combining these two different worlds, the probabilistic world and the machine learning world, we can finally start to see that ghost in the data. So with that foundation laid, let's dive into the actual code and see how it's done.